Welcome to part 5 of the Doppler Secret Ops Beginners series. By the end of this video, you'll understand Doppler's proxied and API rotation models, how to eliminate the risk of downtime with the two-secret strategy, and how to set up secrets rotation for database credentials, IAM users, and API keys. Let's start with a brief overview of secrets rotation. Secrets rotation is a crucial security practice for mitigating the leakage and exploitation of application secrets, but it's often neglected due to the lack of expertise and resources required, fear of potential downtime, and difficulty implementing at scale. The real underlying problem for most organizations is simply the lack of automation tooling across multiple clouds and providers. But Doppler is changing the game with automated solutions for rotating database credentials, IAM user keys, and API keys. Doppler has two distinct secrets rotation models, proxied and API. Proxied rotation uses open source serverless agents that are deployed inside each customer's private cloud, providing Doppler with secure internal network access to infrastructure such as databases. Proxied rotation offers optimum security as Doppler's proxy code is open source, serverless deployments are customer controlled, and rotation resources such as databases don't require public access. API rotation is used when a service provider has public APIs for managing credentials, such as IAM users, Cloudflare tokens, and API keys. How frequently a secret should be rotated usually depends on compliance requirements, such as NIST or PCI DSS, with rotation periods ranging from 90 days to 12 months. Obviously, the more frequently rotated secrets are, the better, but the deciding factor will always be the amount of time required for applications and infrastructure to be refreshed with newly rotated values. And in the case of an emergency, secrets can be rotated instantly via the Doppler dashboard. Now let's look at how to eliminate the risk of downtime when rotating secrets using the two-secret strategy. The two-secret strategy is simply the process of alternating between two sets of credentials, active and inactive, over the course of the rotation period. Let's say we configure secrets rotation for a service with a period of 30 days. Doppler will manage two secrets, secret A and secret B. At day 0, secret A starts as the active secret as it had just reached the end of its 30-day period. The dashboard now shows the value for secret A, but secret B's value remains unchanged as it has still 15 days left in its rotation period. On day 15, secret B's value is rotated and becomes the active secret, as its period began 30 days prior. The dashboard now shows the value for secret B, but secret A's value remains the same, as it's only 15 days into its rotation period. Then, at day 30, secret A reaches the end of its period, its value is rotated, and again becomes the active secret. Now let's see Doppler's secrets rotation in action, starting with AWS Postgres. Secrets rotation for AWS Postgres works for any database instance in a VPC, using a Lambda function as a proxy that provides Doppler with a secure private connection to your database. From the project page, select the environment, scroll down to the rotated secrets section, click Add Rotated Secret, then select AWS Postgres. The first step is creating the Lambda and required IAM and VPC resources. So in a new tab, navigate to the AWS console and check that you're in the same region as your database instance. Let's start by creating the Lambda execution role by navigating to the IAM roles page, then click Create Role. The trusted entity type should be AWS Service. Select Lambda from the Use Case section and click Next. Use the Doppler AWS Secrets Rotation docs to reference the two policies required, then click Next. Name the role and click Create Role. Then create a security group for the Lambda proxy by navigating to the Security Groups page and click Create Security Group. Provide a name, a description, select the same VPC as your database instance, and click Create Security Group. Next, we'll change the security group attached to your Postgres instance to allow inbound connections from the Doppler security group. Head back to the Security Groups page, select your Postgres security group, click Edit Inbound Rules, Add Rule, select the Postgres port, select the Doppler Lambda security group as the source, then click Save Rules. Now we're ready to create the Lambda function. Navigate to the Lambda console and click Create Function. Provide a name, set the runtime to node 16, change the default execution role to the role we created earlier, then click Advanced Settings. Check Enable Code Signing and select Create New Configuration. Enter a description, then from the Doppler AWS Secrets Rotation docs, copy the signing profile ARN and paste it into the signing profile version ARN field. Set the signature validation policy to enforce, then head back to the Doppler documentation, copy the Postgres code URL for your region and paste it into the S3 object field. Click Enable VPC, select the VPC containing your Postgres instance, then choose one or more private subnets. Select the Doppler Lambda security group, then click Create Function. Once the function has finished creating, head back to the Doppler documentation and copy the Postgres handler. Then scroll down to the Runtime Settings section, click Edit, set the custom handler, and click Save. Finally, increase the default timeout by selecting the Configuration tab, click Edit, set the timeout to 30 seconds, and click Save. Then copy the Lambda ARN, switch back to the Doppler dashboard, and paste it into the Lambda ARN field. The Lambda function requires an S3 VPC endpoint to download Doppler's public key for signature verification, so you'll need to create one if it doesn't already exist. To check, navigate to the VPC console, then click Endpoints. If an S3 endpoint doesn't exist, click Create Endpoint, provide a name, then for services, enter com.amazon AWS, followed by the region, then S3, and check the gateway record. Select the same VPC as the Lambda, the route tables for the private subnets, then click Create Endpoint. The final step is to create the IAM role Doppler will assume to invoke the Lambda. Navigate to the IAM Policies page and click Create Policy. Copy the JSON policy from the Doppler documentation and paste it into the AWS Policy Editor. Then from the Doppler dashboard, copy the ARN, switch back to the IAM Policy page, and replace your Lambda ARN with the copied ARN. Then click Next. Name the policy and click Create Policy. Then click Roles and Create Role. Select AWS account, check another AWS account, and paste in Doppler's account ID, which is found in the documentation. Check Require External ID, then paste in your Doppler Workplace slug, which is the value after Workplace in the dashboard URL. Then click Next. Attach the custom Doppler policy, click Next, name the role, and click Create Role. Then click the Doppler role, copy the ARN, then switching back to the Doppler dashboard, paste the ARN into the role ARN field. Name the integration, then click Next to verify the AWS resources have been configured correctly. We'll set the secrets prefix to rotated DB to avoid potential name collisions with existing database secrets. Confirm the rotation interval, set the host and database name, supply the managing user credentials, which should only have permissions to alter user passwords, then enter the alternating users for secrets rotation and click Next to complete the setup process. The final step is to replace the hard-coded database secrets with references to the rotated values, so no application updates are required. With the one-time task of creating the Lambda proxy, secrets rotation can now be set up for any Postgres database within this region in only a few minutes. Let's now move on to secrets rotation for AWS IAM User Keys. Doppler provides secrets rotation for IAM user keys using an assumed IAM role. From the project page, select the environment, click Add Rotated Secret, then the IAM icon. Name the integration, open the IAM user documentation, and copy the JSON policy. Navigate to the IAM Policies page, click Create Policy, then paste the JSON into the policy editor. The default value for resource limits the Doppler IAM role to users whose path contains Doppler rotate. This is highly recommended for providing least privileged access. While you can't supply a path when creating a user through the dashboard, you can work around this by using Cloud Shell and the AWS CLI to create users instead. Back on the Create Policy page, click Next, name the policy, then click Create Policy. Now create the IAM role for Doppler to assume by navigating to the Roles page, then click Create Role. Select AWS account, check another AWS account, and paste in Doppler's account ID, which is found in the documentation. Check Require External ID, then paste in your Doppler Workplace slug, which is the value after Workplace in the dashboard URL. Then click Next. Select the Doppler IAM policy, click Next, name the role, then click Create Role. View the Doppler rotation role, and copy the ARN. Switching back to the Doppler dashboard, paste the role ARN, and click Next. Now we can configure an IAM user for this rotation. We'll set the secrets prefix to AWS rotated to avoid potential name collisions with existing secrets. And I'll choose the IAM user created earlier via the AWS CLI as it meets Doppler's requirements of the Doppler rotated path and does not have any access keys currently assigned. Then click Next to complete the configuration process. The final step is to replace the hard-coded IAM secrets with references to the rotated values, so no application code or CI/CD updates are required. Let's now take a look at an example of API secrets rotation using Twilio. Twilio secrets rotation allows you to rotate both main and standard Twilio API keys. From the secrets page, click Add Rotated Secret and select Twilio. Provide a name, then open the Twilio console, copy the account SID, and paste it into the account SID field in Doppler. Next, we'll create the managing user responsible for issuing API keys by heading back to the Twilio console, click Account, API Keys and Tokens, then create API key. Name the key, confirm the region, set the key type to main, then click Create. Copy and paste the SID and secret value into Doppler, then click Next. Now we can configure an API key for rotation. We'll set the secrets prefix to Twilio rotated to avoid potential name collisions with existing secrets. Confirm the rotation interval and click Next to complete the configuration process. The final step is to replace the hard-coded Twilio secrets with references to the rotated values, so no application code changes are required. You've now got an understanding of secrets rotation fundamentals, how the two-secret strategy is used to prevent potential downtime, and how to configure automated rotations for database credentials, IAM user keys, and API keys. Doppler puts secrets rotation within the reach of any team, with no secrets rotation experience required or changes to application code.